Now, so you have a group 14 chloride. Don't worry about whatever that is being used over here. You are given an equation. And then they say that the HCl produced was absorbed by this sodium hydroxide, and they were in excess. It means whatever number of moles that you calculate over here, they are not going to be completely used up. There will be extra sodium hydroxide. Now, in the titration, the unreacted sodium hydroxide, which is the extra, the extra, they will require this amount of hydrochloric acid for complete neutralization. So they ask you to calculate in number of moles hydrochloric acid. So we just follow the question. Number of moles of HCl is going to be 0.2 times 30 divided by 1000. That's going to be 6 times 10 negative 3. 6 times 10 negative 3 moles. You can just leave it like this. No need to follow 6.00 and so on. No need. Now write the equation for the reaction between hydrochloric acid and sodium hydroxide. Everyone should know how to do this. So it's a neutralization reaction. It gives you salt and water, and it is perfectly balanced. So you just put aqueous, 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 and liquid. So calculate the amount in moles of sodium hydroxide neutralized in this reaction. Now, they say that, this is the number of moles of hydrochloric acid. So I know the number of moles of the hydrochloric acid is 6 times 10 to the power of negative 3. So I need to actually, the ratio is 1 to 1. So it's going to be, it's going to be number of moles of sodium hydroxide, is going to be 6 times 10 to the power negative 3 as well. 6 times 10 negative 3. Now, so later calculate the amount in moles of sodium hydroxide that reacted with the HCl produced by the reaction in equation number 1. Here they say that calculate the amount in moles of sodium hydroxide that reacted with the HCl produced in reaction in equation number 1. So here, if you have, this number of HCl, if this is going to be the number of HCl, wait there, I'm confused. So here, this is sodium hydroxide. So the unreacted sodium hydroxide. So the sodium hydroxide, the one that will react, is the one that is going to be, calculate the amount of moles of sodium hydroxide that reacted with the HCl produced in equation number 1. So it should be the same. It should be the same. Calculate the number of moles of sodium hydroxide that reacted with HCl produced in reaction in equation number 1. In titration, unreacted, it requires this. HCl produced this amount. Reacted. So let's actually find out the total number of sodium hydroxide earlier. The total number is 100 times 0.1 over 1000. That's going to be the number of moles. So this one is going to be 1, 2, 10, 10 times 10 negative 3. So it's going to be 1 times 10 negative 2 moles. So they want the sodium hydroxide that reacted. This is the overall, this is the excess, excess. So I found out the sodium hydroxide that has been in excess, that didn't react. So if I want to find the one that reacted, So it should be 1 times 10 to the power of -2 moles minus with the one that are not reacted that we found just now. So is it 4 times 10 -3? Can someone check on this? Christopher?
Which one?
This one?
Okay, let me check my working. Yes, 0.004.
Okay, so that's going to be the number of moles. So now I found out, okay, the number of moles of the ACl produced was absorbed by this sodium hydroxide. The sodium hydroxide, the one that reacted, yeah. So I know that ACl plus sodium hydroxide, the sodium hydroxide that reacted is 4 times 10 to the power of -3. So if I want to find the number of moles of ACl, okay, that is being absorbed, okay, the ACl being absorbed is going to be the same, okay, 1 mole to 1 mole. Okay, so number of moles, okay, of ACl produced is supposed to be 4 times 10 to the power of -3 moles also. Now, the next question, calculate the amount of moles of XCl4, okay, in the original, okay. So now we already have this. So now I know that, okay, do remember, I do not times by 4 anymore, okay. This 4 ACl is the one that you calculated just now, which is your ACl, which is the ACl that I found out is 4 times 10 -3. One of the common mistake that the student do is, oh, I found ACl, so I have 4. I go and times 4 some more. No, it doesn't work that way. It means this 4 ACl that you produce is 4 times 10 -3. Very important. So now if you want to find this is going to be 1/4 of that value. Okay, so you divide by 4. That's going to be 1 times 10 -3 here. So 4 times 10 -3 divided by 4. So it's going to be 1 times 10 -3. And then calculate the molecular mass. Okay, so we know that number of moles equals to mass over mR. So mR is going to be mass. So the mass is 0.17 divided by number of moles. So 1 times 10 -3. So what is the mR?
It's 170, sir.
17?
170. 170.
170. So 170. And then they say, okay, you calculate the relative atomic mass of X. Okay, so X plus 4 times 35.5, okay, equals to 170. X equals to, so 71, 142. 170 minus 142, you will get 28. So AR is 28. So what is 28?
Silicon.
Silicon. So the answer is silicon. Again, this is also 9 marks. We actually finished this in, I think, roughly 7 minutes.